In this video we're just thinking about the extra considerations that we need to make if we're dealing with definite integrals when it comes to our substitution technique, and particularly when it comes to a change of variable. We just need to be a little bit careful. So given that we already know the technique, I think we'll go straight into dealing with an example. So let's say we're trying to find the definite integral, and we'll do some trig functions again. So definite integral from 0 to pi over 2 of sine x cos squared x dx. Alright, well, recognizing that sine x is the derivative of cos x, or it's actually negative sine x, but that doesn't matter too much. Let's let u be equal to cos x, since that's the one that's squared here. Therefore, du dx is negative sine x. So we're going to express dx as the negative of du over sine x. Alright, so our definite integral, which was the integral from 0 to pi on 2 of sine x times cos squared x dx, is going to be equal to, let's fill this bit out first, so sine x cos squared x is just going to be u squared, and dx is going to be du over negative sine x. Now the reason I've left the bounds off is because we've changed the variable to u now, so we shouldn't really be writing our bounds in terms of x. Now if we're going to, then we just need to be very clear about that. So here's one way that we could do that. We could say x is equal to 0 to x is equal to pi on 2, remembering that they are values of x rather than values of u, which is what our integral is going to be in terms of now. So x equals 0 to x equals pi on 2. Sine x cancels out, so it's just going to be negative u squared du. And so what's that equal to? That's negative u cubed over 3 from x equals 0 to x equals pi on 2. And so a reason for doing it that way is that that reminds us that we can't just sub in the values of pi on 2 and 0 in for u here. We actually need to substitute back in our expression for x. So u is equal to cos x, so that's the negative of cos cubed x over 3 from 0 to pi on 2. So I can get rid of the x equals now because I've got my expression back in terms of x. So it's this, a negative of cos cubed of pi over 2 minus the negative, so plus cos cubed 0 over 3. Now we could have taken, a factor of negative 1/3 out the front. Maybe that would have made life a little bit neater for us. But cos of pi on 2 is 0, isn't it? So the first term is going to be 0, and cos of 0 is 1, so it's just going to be 1 cubed over 3, which is 1, so that's 1/3. That's one way we could do it. There is actually another way which I think is possibly almost a little bit more straightforward, or certainly turns out to be more straightforward in a lot of cases. So maybe, I was going to say I'll just sort of briefly explain what that is, but I think I will actually do it again. Let me grab, just to save a bit of time, let me grab sort of all of this bit here, and let's start off with that, and then say, alternatively, once we get there, we could also change, when x equals 0, well, u equals cos 0, which is 1, and when x equals pi on 2, then u equals cos pi on 2, which is 0. So if we do it that way, then when we get down to the stage where we're saying definite integral from 0 to pi on 2 of, not cos, sine x cos squared x dx is going to be equal to, now because I'm changing the variable to u, I'm also going to change the bound. So, and I know that looks a bit odd at the moment that we're going from 1 to 0, but that should give us the right signed value here. So sine x u squared du over negative sine x. Sine x's cancel. We've got negative u cubed over 3 from 1 to 0. So let's say that's negative 1/3. And u cubed, so that's 0 cubed minus 1 cubed, which is just going to be negative 1/3 times negative 1, which is positive 1/3, which we know from doing it the other way was the correct answer. Now I think that's possibly a little bit easier because often the expression we've got for u is a fair bit simpler than the one in terms of x, so it's actually easier to just substitute in for values of u. So as long as we change the bounds to be values of u, we can leave it in the variable u when we're doing a definite integral.